So logic gates. Under logic gates, let's write down logic circuits are fast switching circuits where the input and outputs are binary numbers. So what are the binary numbers? It's 0 or 1. So the input and the output only can be 0 or 1. So here, low voltage, we consider low voltage is considered as 0 and high voltage as 1. There is only two possible values, 1 or 0. In that, low voltage is 0 and high voltage is 1. And we can use this 0 and 1 for different logic conditions. 0, 1, or these binary values. The binary values are used for different logic levels or different logics. Example, for example, we can consider example 1. Pass is 1. For pass, if we use 1, and fail is 0. If we use pass is 1, then fail has to be 0, the opposite, or vice versa, or the other way. Then, for example, we can tell door open is 1, and door close is 0. So on, depending on the situation, we can use 1 for certain logic and 0 for the opposite logic. Okay. Next point, to deal with this logic circuit, there is a special algebraic notation to operate with logic circuits. George Boole expressed a special algebraic notation. So here, according to and it is called as, and it is known as, it is known as Boolean algebra. So here in Boolean algebra, we have some special algebraic notations. First one, 0 plus 0, that is equal to 0. Have you all studied ICT in your O levels? Have you all done ICT? Those who did ICT in your O level? You all do? Yes or no? Can hear me, right? Raja and Sarah, did you all do ICT in your O levels? Okay, so there you might have learned about that we have something called O gate and AND gate. We will be learning now to understand this Boolean algebra. It will be helpful. So, and not gate. Okay, don't write this. So, O gate, let's say we have two input. We have two inputs. Both of them is low. If both of them are low, then the output also will be low. If one of them is high, one of them is high, A or B, one of them is high, then output will be 1. If both of them are high, then also output will be 1. Okay, that is for OR gate. And we use the sign plus to show an OR gate. In case of AND gate, for AND gate, from its name itself, you should understand this one and this one has to be high. Both of them has to be high. So if both of them, this is 1 and this is 1, then only the output will be 1. And we use dot to show a OR gate. NOT gate is simple. If you give 1, the output will be 0. If you give 0, the output will be 1. It will just invert. Okay. So using this idea, look, the first one, 0 or 0. Obviously, it is going to be 0. 1 plus 0. Now it will be 1 because at least one of them is high. Third, 1 dot 0. That means both of them, if both of them are high, then only it will be 1. Here only one of them is high, therefore the output is 0. Fourth, A plus A. A plus A. A plus A, it's like this. Now let's say this is A, the input is A. The input is A, then what will be the output for OR gate? So that means, let's say A is equal to 1. A is equal to 1. Then this is 1, this is 1, then the output is 1. If A is equal to 0, then this is 0, this is 0, then output is also 0. So A or A, the output is A. Fifth, A dot 0. For A dot 0, both of them are not high. One of them is low. Therefore, the output will be low. Sixth, A dot A. Both of them are high, so the output will be A. Seventh, A dot A bar. That means now we are using dot. Dot means it's an AND gate. In AND gate, we know both of them has to be high. Now this is A and this is A bar. So if A is equal to 1, then A bar is equal to 0. So 1 and 0, output will be 0. If A is equal to 0, A bar will be equal to 1. So this is 0 and this is 1, still the output is 0. Therefore, A dot A bar is equal to 0. Eighth one, A plus A bar. Using the same idea, if this is 1, this is 0. So anyhow, one of them, if one is 0, the other one is going to be 1. Therefore, A plus A bar is equal to 1. Ninth, bar of A bar. Bar of A bar is equal to A. 10. It doesn't matter if we change the order. A plus B is equal to B plus A. Okay, if we write it in the opposite way also, it's not a problem. So we call it as commutative. It's commutative. Are these 10 clear? Similarly, A dot B and B dot A, they also won't make any difference. It's similar. A dot B is equal B dot A. 12th, this is special. A dot B, we can write them as A bar plus B bar. Here A dot B whole thing bar could be written as A bar plus B bar separately. And similarly, if we have A plus B whole thing bar, this one could be written as A bar dot B bar. A bar dot B bar. Not whole thing bar, separately bar. And then we have A plus A bar B. A plus A B is equal A plus B. 15th, A plus A bar B is equal to A plus B. I will explain the 14th and the 15th. Other than that, the other 13, are they clear? Saja and Shahama. So when you are simplifying, you don't need to remember this. If you remember what is and then or, then it should be easy. Shahama, okay, clear. Now let's look at the 14th and the 15th. Let's prove it. Example 1. Prove A plus AB is equal to a plus b. So let's consider the left hand side. Left hand side is equal a plus ab. Just like in normal algebra, we can take a common. If I take a common, I have a brackets 1 plus b. So b plus 1. This doesn't depend on, oh, 1 minute. Sorry, this is a plus a plus ab is equal to a. Correct it, not a plus b. So here, look, b plus 1. Does it depend on b? No, right? Because here we have 1 or b. Because already we have a higher value, it doesn't matter what b takes. Even if b takes 0 or b takes 1, still the output is going to become 1. So we have a dot 1. When we have a dot 1, now the output depends on a. If a is 1, the output is 1. If a is 0, the output is 0. Therefore, the output is a, which is equal to RHS. Okay. We have to prove a plus ab is equal to a. Is that clear? Now let's prove this. LHS left hand side is equal a plus a bar b, but from previous we can write a as a plus b, but a is equal a plus b, therefore equal a plus a b plus a bar b. So this is equal here between these two, a is common. So a plus a b plus b bar. Sorry, we can take b common. We can take b common. So we get a plus a bar. So what is a plus a bar equal to? Now, if one of them is a, if one of them is 1, the other one will be 0. If a is 0, a bar will be 1. Therefore, anyhow, the output is going to become 1. So this is 1. This is 1. And we get the answer as a plus b, which is equal to the right hand side. Okay, is that clear? Shall we try one more? Example 3. Show ABC plus ABC plus AB bar C plus ABC bar. ABC bar is equal AB plus AC. Can you try? So let's take one side and start to simplify. See if you got this answer. So here I considered these two together because I have AB here. I took AB common, then I got C plus C bar, which is equal to 1. And between these two, I took A common, then I got B plus B bar C. So we know B plus B bar C could be written as B plus C. And again, just expand. Are you okay with example 3? Try the next one. I think we can simplify further because we get the answer in a single step. Let's see if we can simplify further. Instead of A, I can write, and don't write the one I'm writing now. Let's see if we can simplify it further, okay? Instead of A, I can write A plus AC is equal to A, right? A plus AC is equal to A. So A bar is whole thing bar. We can write this whole thing bar as A dot AC whole thing bar. Mm, and this one could be written as A bar plus C bar. Then we get A bar dot A bar plus A bar dot C bar. So this one can be written as A plus A whole thing bar plus A bar C bar. No, it's getting long lengthy, right? Let's leave it here. Okay. I can note it. Okay, the meeting will end in a minute. I will stop and start the next meeting.